Okay, so once again, good morning. So of course, many businesses rely on their IT systems, no, to manage data, facilitate payments, and run operations. So unforeseen bottlenecks can occur when IT runs unnecessary system upgrades. So if the implementation stall and temporarily keeps your business from running smoothly, to combat this, some IT systems have statistical algorithms that find the likely cause for the blockage before your business hit a dead end. So other operational benefits of statistics are accurate demand forecasting and sufficient inventory planning. So in steering the direction of your business, statistics can be used to guide long-term forecast for strategic planning. So analytic methods like statistics support the understanding of the holistic impact the strategic initiative can have on your business. So let's say, for example, a statistical model can provide a baseline forecast of your revenues and expenses for years to come, which your team can adjust depending on new product introduction, new markets, and competitor activities. So instead of repeatedly reacting to lost sales from insufficient inventory, you can use statistics to learn about your customers' behavior, like how they react to promotion and when and what the way they buy. So there are some research studies allowed businesses to be proactive through predicting customer behavior and creating better marketing plans. Moreover, statistics can be used in the development and pricing of new products via survey, analysis, and regression model. Okay, to give us more details about the value of statistics in data treatment and making decision, let us all welcome our presenter, Madam San Juan.
And making decisions. Statistical data are the numeric values, items of information, or other facts collected, numerically grouped into definite classes for analysis relative to a particular study or research. And when we say statistical treatment of data, it is the application of statistical method to a data set to transform it from a group of meaningless numbers into meaningful output. So what is the value of statistics and treatment of data? Statistical treatment of data greatly depends on the kind of experiment and the desired result from the experiment. Statistical treatment of data allows a researcher to organize and process the data collected to be able to identify trends, patterns, or relationships. So how are we going to determine the data and the treatment we use? The following should be useful in guiding what data is relevant and determine how the data will be treated to answer or address the question or research. We have the statistical objective, number of variables, the kind of data, correlation or dependence. These are the 5 statistical objectives. Description. When we want to describe or characterize populations and samples using descriptive statistics, graphs, and maps. Classification. When we classify, identify, and categorize a sample based on its characters, uses descriptive statistics, graphics, and multivariate techniques. Comparison. When we look for differences between populations, samples, or reference values. Prediction, where we can predict future measurements using regression, time series, analysis, or spatial interpolation. Explanation, we are looking for the most important drivers of variation in the data to try and understand what is going on. The number of variables. Variable is a specific characteristic of an individual or object relative to the subject. A study, a research can have one or more variables. It can be categorical or numerical. A categorical variable gives us responses to yes, no questions, or strongly disagree to strongly disagree. While numerical is of course counting or using numbers. When we say independent variables, these are manipulated, controlled, or are changed by researchers and whose effects are measured and confirmed. When we say dependent variables, these are completely dependent on the independent variables. The kind of data. Discrete data can only take particular values. There are no gray area in between. Categorical or nominal discrete data counts or frequencies of things in two or more groups or categories, with no intrinsic ordering to these categories. For example, the eye color, the gender, or the species. Ordinal data are counts or frequencies of things in two or more groups, but with intrinsic ordering to these categories. For example, the level of education. It should be from elementary school, going to high school, going to college, and going to postgraduate. Interval data counts or frequencies of things in two or more groups with intrinsic ordering to these categories and where the spacing between categories is equal. An integer is a numeric data which can be discrete if we are counting whole things, for example, the number of apples, even if there is potentially an infinite number of these things. We also have the continuous data. These are not restricted to any particular set of values and may take a continuous range. Correlation or dependence. Observe that the variables may be correlated with each other in some way. It is a statistical association, though it commonly refers to the degree to which a pair of variables are linearly related. For example, a particular variable may be related to time, space, or a sequence. Statistical treatment of data also involves describing the data. To explain how the data are concentrated, we are all familiar with the mean, median, and mode, which is a measure of central tendencies. To help us understand the distribution of the data, we have range, uncertainty, and standard deviation. For test of relationship between variables, there's hypothesis testing, coefficient of correlation Pearson, coefficient of correlation is Spearman, chi-square, Kramer's B, regression coefficient. And to test the difference between groups, there's t-test, one-way ANOVA, two-way ANOVA, Friedman analysis of variance, and Kruskal-Wallis H-test. Most of this will be discussed in detail in succeeding reports. Choosing the statistical test. After determining the purpose of the study or the research and listing the kind of data required, below is a simple guide in choosing the appropriate statistical test or method to be applied. Here is a simple diagram that might help us for selecting a statistical method. So first, we need to answer how many variables do we have. Let's say more than one. Are some variables dependent and others independent? Let's say yes. Are the dependent variables autocorrelated? For example, it's not. Then we're going back to the objective of the research or the study. Are we to describe, classify, compare, predict, or explain? For example, we are to compare, and that means the ANOVA test and the suggested methods that we take. A fundamental part of statistical treatment is using statistical methods to identify possible outliers and errors. It's also part of an analysis and correct results reporting. Results should always be reported along with some estimation of the errors involved. The statistical treatment of data involves reporting the most likely error value along with the confidence interval. There are two types of error, type 1 and type 2. Type 1 is also known as a false positive and occurs when a researcher incorrectly rejects a true null hypothesis. This means that you report that your findings are significant when in fact they have occurred by chance. Type 2 error is also known as a false negative and occurs when a researcher fails to reject a null hypothesis which is really false. Here, a researcher concludes there is not a significant effect when actually there really is. Outliers. Statistical outliers are data points that are far removed and numerically distant from the rest of the points. One should be careful while dealing with outliers and not mistake them for experimental or exceptions. Outliers can indicate a different property and may indicate that they belong to a different population. Here are some common statistical errors. First is correlation is not causation. It means that just because two things appear to be related to each other, it doesn't mean that one causes the other. Biased data. Biased sampling that can lead to measurement errors because of unrepresentative samples. Regression error. These are mistakes arising from not knowing what should be tested on the regression table. One must find out if there is any functional relationship between the variables that are being considered. Misunderstanding the p-value. P-value do not measure the probability that the studied hypothesis is true or the probability that the data was produced by random chance alone. Thus, business and organizational decisions should not be based only on whether a p-value passes a specific threshold. Inadequate handling of outliers and influential data points. Outliers should be investigated and deleted, corrected, or explained as appropriate. Lastly, loss of information. A loss of information in individual data points can impact the result and its relationship with dataset. The value of statistics in making decisions. Statistics provide managers with more confidence in dealing with uncertainty despite the flood of available data, enabling managers to more quickly make smarter decisions and provide more stable leadership to staff relying on them. First, statistics matters more than ever in this age of big data. Information overload can be a problem for leaders and executives aiming to make more informed, evidence-based decisions. Statistics collect and converts data into usable information and actionable steps. Second, is making sense of mountains of data. Statistical analysis enables a business to gather and understand segments of data in order to identify patterns and other realities relevant to both past and future success. Leaders can then utilize this analysis in a number of helpful ways, including evaluating the performance of staff and determining paths to improvement, identifying patterns in consumer preference and behavior, predicting product performance based on past performance and emerging trends, auditing the efficiency of various processes, and evaluating geographical realities within sales or other processes. Statistics can reveal the future. Forecasting or predictive analytics has proven to be a helpful way for decision makers to arrive at truly informed assumptions about future events and trends. Some specific applications already demonstrating success include higher performance in financial trading, improving diagnostic, treatment, and administrative processes in healthcare, better understanding and prediction for marketing and advertising strategies, detailed scientific modeling for pharmaceutical development, customer demographics and trends for retailers, and enhanced testing and teaching methods in education. Statistics saves and makes money. Businesses utilize statistics in a variety of areas that affect their bottom line, including performance measurement, forecasting conditions, production and sales, analyzing risk and return on investments, and market research. Lastly, statisticians empower leaders to make better decisions. Statisticians help decision makers avoid common analytical traps, including confirmation bias, where the executive only sees what they already believe to be true in a report, as opposed to the more objective interpretation of the data, and overconfidence, believing an analysis is covering more than it really does. The danger in confirmation bias is keeping the leaders stuck in the past, relying on past practices that no longer lead to future success. A trained statistician can assist an executive in identifying and understanding the results of the analysis on the best allocation of resources. The statistician can also help keep goals realistic and measurable to help minimize the errors and waste. That's the end of my report. Thank you.
Okay, so thank you very much, Madam, for your comprehensive discussions of the topic. So, again, statistical research in business enables managers to analyze past performance, predict future business practices, and lead organizations effectively. So statistics can describe markets, inform advertising, so set prices, and respond to changes in consumer demand. The descriptive analytics look at what has happened and helps explain why. So by using historical data, managers can analyze past successes and failures. And this is also called cause and effect analysis. And some common applications of descriptive analytics include sales, marketing, finance, and operations. So predictive analytics uses a variety of statistical techniques, no? So as what our presenter mentioned earlier, no, she able also to provide with us on how we'll be able to identify the correct statistical tools a while ago, no? And this goes beyond reporting what was happened to create best estimates for what will happen. So some common application of predictive analysis include fraud detection and security, risk management, assessment, marketing, and operation. Again, prescriptive analytics is the stage of determining the best course of action in a given business situation. This includes knowing what may happen, why it may happen, and how to navigate it. Constantly updating information changes prescriptive analysis, allowing managers to maintain action plans for their organization in real time. Okay, so again, statistical research gives managers the information they need to make informed decision in uncertain circumstances. And this will be the value of statistics. Now, when managers analyze statistical research in business, they determine how to proceed in areas including auditing, financial analysis, and marketing research. So I think that's it for this topic.